Alright, welcome to part 2, the final part of 3.3 Properties of Logs. Our essential question is, how can we model a real-life situation with a log equation? So we're going to talk about expanding and condensing logarithmic expressions. We're going to use the product, quotient, and power rule in order to do this. This is just a recap of our rules. I would write them down, or take the resource that's posted on the Moodle page. So when your product rule is if you're multiplying the log, that really means you're going to add the two separate. If you're dividing, you're really going to subtract. And then if you have the power, you're going to multiply them. So let's expand this problem. That means you are going to take log b, x to the fourth, and we're going to rewrite this as x per y to the 1/3. So now you can take this, and it's going to be log b x to the fourth plus log b y to the 1/3. So that was our product rule. And now we're going to do our exponent rule, or our power rule. And this is your expanded form. So I took a shortened version, I expanded it all the way out. So it's expanding log. Let's do another example. So you take this for it's x to the 1/2. Alright, so now we're going to go from here and we can do, we have a quotient, so we are going to separate it by subtraction. If you look, this is your product, so we're going to write the product part out. And now we're going to simplify this. We have to add in. I'm going to do a couple different things at the same time. So I'm going to do my power rule here. So that means I have 1/2 log 5x minus, I'm going to leave this part for now. Eventually I will be able to change that by, it's going to become subtraction, and I'm going to bring my 3 down. Alright, so I mentioned before that I was going to be able to simplify this part right here. So this goes back to converting it into, so you have 5 x equals 25. So x is going to be 2. And this is your final answer. You do want to make sure you simplify this into the 2. So anytime you have a problem where you have both your sets, you can try and think about what it would be. So this one we're going to condense our logs, so we're going to make them smaller. So if I have addition, that really means that I'm going to multiply. (25 times 4 is 100. Remember, this is log 10, and we've done this one before, so you have log of 100, and your answer there will be 2. This is again our rule. So in this case we have subtraction, which really means you have division. And that's your final answer in this one. So next one, there are a couple steps you're going to have to take. You have a power, so that means we're going to have ln x squared plus ln x plus 5 to the 1/3. the other way of writing this portion is your cube root. So now we can condense this even more, so you have ln x squared times your cube root x plus 5. That is my condensed version of what they gave you to begin with. So another rule that we're going to talk about is called the change of base property. So if you're given log sub b m, that really means you have log a of m over log a of b. Let's look at an example. Well, we're going to look at, so the common logs, log b of m is log m over log b, and natural log is log b of m is ln of m over ln of b. So if you look back at this one, you have an a. So in this case, since you're doing your common logs, it's going to just be sub b, so it's just log. Let's look at an example. This one says using common log, change it. So you want log of m on your top and log of your b on the bottom. So if we were to pull up our calculator, you have log of 2506 divided by log. So your answer is going to be about 4.02. The next one, it says use the natural log, so that's your ln. So that means we're going to have so let's use the calculator. Clear that. And you should get the same thing. So it's about 4.02. And that is your answer. So make sure you complete the questions below and you work on your homework, and I will see you in the live class.